Salmonella survival in peanut butter. If you pay attention to the news, you've probably heard about a number of salmonella-related outbreaks and their subsequent product recalls. Notable cases involved Peter Pan peanut butter, King Nut, Great Value, and Peanut Corporation of America. In 2009, lack of quality control resulted in the distribution of King Nut peanut butter contaminated with Salmonella typhimurium, a pathogenic strain leading to typhoid-like symptoms. This incident led to 714 individuals being infected across 46 states and a lengthy prison sentence for company executives such as Stuart Parnell, a former owner and executive at Peanut Corporation of America, who got 28 years in prison for his role in a recent salmonella outbreak. Why salmonella survives in peanut butter? Peanut butter products have both a very high fat content and a very low water activity, traits that would seemingly make contamination very difficult. So why do these salmonella-related outbreaks keep occurring? The answer is simple. Salmonella may not grow in the environment created by peanut butter, but it can survive in impressive fashion. In various studies, it has been shown that dried salmonella cells found in these low water activity products, such as peanut butter, actually develop a higher tolerance to bacteria-eliminating processes such as heat treatment, irradiation, and treatment with ethanol and sodium hypochlorite, among others, a phenomenon that we will discuss further with you in this presentation.
Well, salmonella outbreaks are often associated with dry commercial processed food, such as peanut butter, snack crackers, etc. While salmonella may not be able to grow at low water activities, it is certainly capable of surviving. The current industrial standard for water activity in peanut butter is 0.7, and the minimum pH and water activity value that permit growth at 3.94 and 0.942. In many studies, it has been found that this low water activity enhances salmonella's ability to survive in industrial treatment, in several industrial treatments actually, such as thermal processing, radiation, and exposure to ethanol and sodium hypochlorite. Actually, the lower the water activity, the higher the resistance of salmonella to heat and other industry processing treatments. Basically, no matter how bad you treat salmonella in low water active environment, they're gonna finally survive. Just like Leo in the Revenant. But unfortunately, on a positive note, even though salmonella survive in lower activity products, their number constantly drop log by log and day by day. In the data from the University of Georgia has shown that some salmonella will survive over 102 days in filling cookie and cracker sandwiches, but most of them die out about in 70 days. And according to another study, salmonella cells in peanut butter stored in room temperature will die out after approximately 6 months. And another fact is that salmonella is less resistant to treatment with organic acid, such as acetic acid and citric acid, at a pH of 3. And according to the research from Harvard University, when the salmonella is treated with organic acid, their population is reduced in 1 log in 2 hours when they are in the wet food products, and 3 log in dry food products. So, this might be the way to further treat industrial food products moving forward. See that sad baby face.
Desiccated salmonella cells were proved by above studies to have higher capacity to survive under industrial processing methods. Therefore, many studies have focused on increasing water activity in peanut butter and its influence on salmonella survival. The result is that increased water activity reduces the thermal resistance of salmonella in peanut butter. Therefore, food companies can increase water activity in peanut butter by adding less salt and sugar in it to allow for better sterilization. However, the disadvantage is that higher water activity in peanut butter would lower the quality and taste of the product. According to one study, less sugar and water in the peanut butter would significantly increase the flavor. In addition, low water activity would effectively control mold growth. Thus, it is not recommended to increase water activity in peanut butter. Therefore, we recommend two other ways to prevent Salmonella infection. First one is sanitation. According to previous report conducted by CDC about Salmonella outbreaks in peanut butter, contamination is often attributed to poor plant sanitation and disqualified ingredients. Many studies have indicated that chemical utilized for sanitation of food contact surfaces, as well as thermal treatment of dry foods, might not always be sufficient to ensure efficient eradication of human pathogens. Existing sanitation protocols and the process of microbial inactivation of food items in all food sectors should be revisited and examined to confirm the anticipated results. The finding about the enhanced susceptibility of dry Salmonella cells to the organic acids might be useful in devising improved decontamination methods for dry surfaces. Therefore, more strict HACCP plans and GMPs should be created and used in food industry to avoid Salmonella outbreak. Production date. Food product with low water activity like peanut butter can be stored for over a year, and based on multiple studies, most Salmonella will die out in 3 months. Therefore, we suggest customers purchase products that were produced 3 months ago for dry crackers and fruits, and 6 months for peanut butter to prevent possible Salmonella infection. In order to know how long the products are produced, new regulations for peanut butter producers to label the production date is necessary. In conclusion, while Salmonella does not grow at low water activities, it is incredibly adept at surviving, making the use of proper sanitation and quality control practices in the processing of products like snack crackers and peanut butter all the more important.